So hello everyone. Today I am solving Codeforces difficulty level 1500. Okay. So I am solving these four problems: 690 to 1673. See. Okay. This is the first problem. So a batch of n good and is an even number is brought to store, height of which is having weight AI. Before selling the good, you must be packed into packet, and after packing there will be done. There will be n by 2 packet. Each packet have exactly 2 goods. The weight of the AI plus j, the cost will be x by k. Okay, so we need to minimal the cost. We have to maximize the cost. Okay, so sign. Okay, so what we are given is that we are just given an array from a1 to a of n. Yeah, of n elements, and n is a1. N is a1. So we have to make something like that: ai and aj in a packet, and its sum will be ai plus aj, and its cost will be let's say its sum is s, so s by k with lower bound. It is the cost, so we have to maximize the cost. So you can see that, like, we can maximize I can say that. So basically we have to play with the remainders. So how can I see that? So basically, like, a if 3 4 5 or 6, okay, and let's k is equal to 3. So here come value 1, here also divided by 3. Okay, let okay, divided by 3, divided by 3, divided by 3. So value will be 1 1 1 and 2, but here we have remainders. Okay, remainder is 2 and 1. Yeah, here is 1, here is 2. So these values are 1, but we have some remainders. So if we are playing something like that, such that, so remainder will also increase our answer, something like that. If like k is equal to 3, and like if 5 is there, so remainder will be, for 5 remainder is 2, and for 4 remainder is 1. So it will increase our count by 1, like 4 5 by 3 is 1, 4 by 3 is 1, but 5 plus 4 by 3 is 3, because of the remainders. Remainder also increase, that will be 9 by 3 is 3. Okay, because due to remainder, so we have to play with the remainder, such that uh, remainder we have to maximize the remainder. Like if in case of 4, the remainder will be 1 2 3 4. Okay, if uh, if any of the number gave like something 5, 5 gave a remainder with the 4 is 1. So we have to mix up with it, k is equal to 4. In this case, we have to mix up with k minus what is the current remainder is r. So here it is 3, so I have to mix up with this with 3 or greater than 3, such that it will also give me, it will increase the answer that I need to do. So first of all, what I will do is, I will take an I will make array. So let me erase all these. So basically, we from all these I conclude with only with a statement that we have to play with the remainder, and we have to, like, if I have two remainders a1 a2, I have to sum up the remainders such that a1 plus a2 is greater than or equal to k. That I want to do. So first of all, for or I will take the remainders, that will be r1 r2 to rn, and for, like, I can do this now. I can do from here, I can do with two set by I can do with the multi-set, or I can do by two pointers. Both will give me the same complexity, that will be on all level of n, because multi-set will be given log of n for every insertion or deletion, and two pointer, for two pointer I need to sort the array, that will be n log n. so both are good. And the range of n is also 10 to the power 5, so n log n will work, so we don't have to worry. So first I will say how we can do with the multiset. Okay, then second we will see how we can do with. So for the multiset, what I used to do, like, let k is equal to 7. Okay, and remainder be 1 2 2 3 3 and 5 6 6 6 6 6. Let these be the remainder. Okay, so for the, like, I will iterate over the multiset and take out the first element, the begin, that is 1. I will and erase from here. So I will erase 1 from here. So I will see. And now to make our increase our answer, so I need k minus 1, that is equal to 6. 6 or greater than 6, I will search for the lower bound of 6. If I found 6 or greater than 6, I will say, oh yeah, I 6 is there, so I will increase my answer by 1. Okay, so I will rub the 6 here from here. Again I will take out the maximum element, that is 2, and k minus 2 will be 5. So I will search for 5 or greater than 5. So 5 is there, so this will be raised and this will be raised. Now I will see if 2 is, for again 2 is there, so I will search for 5 or greater than 5. So 5 is not there but 6 is there, so I will rub by 6. So I will take 6. Similarly, this 3 will take this 6 and this will take this 6. So accordingly we count the answer. So first way is this, using the multiset. You can do this by multiset. So come to the second answer using the 2 pointer. How can we do by the 2 pointers? Mhm. So first of all, I have the remainders array R. So I need to sort the array. In multiset I don't need to sort the array, because in multiset it will automatically sort. In when I store in the multiset, it will automatically sort the array. So let's say now I will the sort will be 2 2 3 4 and k is 7, and I will say 6 6 and 5 I will say, and here I will say, mm, wait a minute, so I can give you uh, all the examples, like if I say 3 4 6 and yeah, mm, that will be good, that will be good. Yeah, that is good, that is a good example. So I have this example. I have array of while after sorting I will get an array of 2 1 2 2 2 3 4 5 6 6. Okay, so let me write it here. So 1 2 2 2 3 4 5 6 6. So I will take two pointers, I and j. I is pointing here, and let me rub all these, and j is pointer here. J is pointing here, the first and last element. If I see sum of I and j, that is 1 and 6, if it is greater than 7, yeah, it is greater than 7, I will increase the sum, and I will increase the I and decrease the j. So now I will point at 2, here is the I my, and j is point at 6. Now I'll see that sum of 2 plus 6 I and j is greater than 7. Yeah, it is. I will increase my answer and um, increase the I and decrease the j. So here come my I is this one and j at this position. Now I'll see 2 plus 5. Yeah, it is also, so I will do the same thing. Now I will point here, this is my I and j is here. Now here the point. So the sum of I and j will 6. So it is not greater than or 7. It is not greater than or equal to 7. So what we have to do now? So now so we have to increase the sum of I plus j, such we have to move I and j such that we should increase the sum of I and j. So this is an increasing array. If we decrease then the j, let me decrease the j minus 1, I will definitely show that this is increasing array. If here is 6 value, 5 value, so next will be less or smaller than 5 or maybe equal to 5. So that will not give me an result, more result, matlab higher increasing result. Okay, so then if then I plus j minus 1 will not increase my answer, so I need to increase from 6 to 7. So what will do, if I increase the I, okay, the second option is I should increase the I. If I increase the I, then I definitely say that this is an increasing array. I plus 1 is definitely greater than or equal to I. Okay, these value will be greater than or equal to I. So here like 3 is greater than or equal to 2 because this is an increasing array. So in this case, if a sum is not equal to 7 or less than 7, then I will increase only I and don't change the j. So now I will be 3 and j will be this one. So I will I and j, that is 3 plus 4, it is greater than or equal to 7. So I will increase my array, and now and increase I plus 1, I will point here and j will point here. So I will exit from the while loop, because the while loop is running up till j is greater than or equal to I, that I, or I will say not greater, I j is greater than, because when it is one element this, okay, by the way this is even, so nothing problem. So I is great. So let's see the code. So I will code according to this two pointer. Okay, so I will take an n c, wait a minute, cn, and I will take a vector of a, let me say and long answer is equal to 0 for, I will say it as remainder, that will be more good. Int I is equal to j I less than n plus plus. So int x, I will take int cns. So first of all I will take out my answer like, okay, it will given k also, x and int k. Okay, here is the k, x divided by k, that is my, that will definitely increase the answer. But here is the remainder, I will push remainder dot push back, that is x remainder by k. I will say x remainder of k must be greater than 0, or both are fine, so we don't have to worry about that. If it is 0 then it is okay. Now I need to sort the array, that is ram dot begin and ram dot end. Okay, so int I is equal to 0 and j will point into n minus 1 or ram dot size minus 1. Basically it is size of n because I also pushed the n, that is okay. So I will be less than equal to j. So if a of I, that is ram of I, that is remainder at ith position plus remainder at jth position, if it is greater than or equal to k, what I will do, I will first of all increase the answer, and I will increase the I and decrease the j. Else if ram of I, that is the only case, like if it is not, it is sum is less than, then I will only increase the I. Okay, yeah, now I will output the answer. Okay, 80205 84020, yeah, looks good. What? Yeah, it is okay. So this is the second problem. So the hard version. Okay, sorry for this. So we are just given an array and there are a terminal in a row of n equal segment 1 to n in order. There are two terminals. So kind of two terminals. So PI state wire is connecting two terminals from here to here. So we need to find out the maximum number of intersections. Okay. So we need two terminals. This is the first, let's say. This is the second. Let's say this is 1, 2, 3, 4, 5 and 6. Here same 1, 2, 3, 4, 5 and 6. So how can a terminal intersect? When will the intersection will happen? Like this terminal, okay, this terminal connect to a wire 6 and any of its smaller terminal from here to here is connecting a wire greater than 6 or equal to, that will be okay. I will equal to case I will handle in the end. And if it is connecting greater, if smaller of any smaller terminal will connect a wire to a greater terminal, then there will be an intersection. So these are the intersection. Okay, so intersection will happen. Now second case, when these connect to a single, okay, to a single platform, what will then happen? If like this connected to this one only, same this also connect this and this connect to this. So if on a single platform 3 wire are connected, so what is the maximum number of, then the maximum, then like if there is one wire, so it will not cutting to anything. If there are two wire, then it will connect cut to one. Okay, if there are three wires, then three will decide to cut both of the two. Similarly 3, 4, 5, 6. So if we have like 4, sorry, 6, like if we have like 4 wires, then the fourth one will cut all of these wires. So if we have 4 wires, then some will be this one, and if we have 3 wires, then some will be 1 plus 0 plus 1 plus 2 plus 3 plus 4. Okay, for n the sum will be n into n minus 1 by 2. So in this case we don't see. So I will break this problem into two cases. So first case, I will check only for smaller element, okay, like only for intersection which is not on the same platform. So it will be not on same platform. In second case, I will take care of the same platform intersections. So here I will take care of the same platform intersection. For every platform I will take how many uh, wire are there, and according to that from using this formula I calculate the intersections. So how can I calculate this problem, the first part of this problem? So this, by the way, this is the classical you can say this is the classical problem of type inversion, like count the inversion. This is a classical problem. That is, if for any I, if j is greater than or its value, here is the connecting terminal is greater than, okay. So what we are doing for, like for the 4, I will like it connect to 6, for any j that is greater than I need whose value is greater than. So here I will find the greater values. This is the classical problem. So we can do with this one with segment tree, bit, binary industry, or I can do with the modification of what the merge sort algorithm. But this need a lot of code to write. This is very good. I prefer this one, bit. So if you don't know about the bit, so you can read about the bit on Hacker Earth. Yeah. So let me show you where you can read about the bit. This is a little bit advanced data structure, but it is good if you learn about bit. So this is the binary Fenwick tree or bit binary index tree. Okay, this is the tutorial. Read about this. So I am using only these two algorithms. So first one, this is the update, and this is query. By the way, what I need a sum. Okay, if you basically see what I need a basically sum. So what I will say, let at 4 I will update in the binary industry, my sum is 6. Let's say sum is 3. Okay, so value is 3 and value is 6. Value here is it connect to 4. Okay, let me, so what a basic example what a bit can do. So let this connect to 4, this connect to 3, this 4 connect to 6. So when I come to 3, let it connect to 5, it connect to 5. This all in the bit. So bit will give me sum which are greater, smaller than 5. Okay, in log n time. So that will be good. So it will give just to give me a sum in just log n time. That is, there are two number which are smaller than n. That I will. Okay, let me code this. So which, yeah, no, this is the problem. Okay, so what we are given, a single n, you can also search different I will say this can be done by the three techniques. So merge sort is also, like, you can search inversion count using uh, here is merge sort, like you can see that inversion count using, yeah, here you can see that by merge sort, by Fenwick tree, by segment tree, by order set, all these are there are many you can do by many tricks. Okay, and a of n, me, okay, sorry for that. Or I will take input of the array C a of I, and I will make a terminal like terminal of a of I, matlab at this particular terminal how many wires are there. Okay, so I will iterate over, I will iterate, and I is equal to n minus 1, I must be greater than equal to 0, I minus 1. So what is the n? So I will say constant max is equal to n can be 2 into 10 to the power 5, 2 into 10 to the power 5 plus 10. Okay, I will create a long bit of size maximum. Okay, and yeah, only there are only, like, for fan factory there are only two queries. Like I will copy in this for the queries, return the sum. Let's do it. And another one is update. Yeah, update will be a code type. Int value int at index okay. And the thing is, both of these codes are same. Like I will write it like 4x is less than maximum, and x will plus x into minus x. This will do. So I will say bit of x will increase the value. That's it. So I will take answer long answer is equal to 0. So I will say This is my long. Mhm. So I will increase the sum by query of the sum of a of I, that is smaller than this. How many are smaller than this? A of I minus O, yeah, of I minus 1, and I will update this in the my binary index tree. Okay, that is AI at index I. Okay, so sorry, value 1 I, this value and index. Okay, value and index. Okay, yeah. After that I will iterate over. Now I will, the second part of the problem, uh, count on the same number of wire intersected on a single same platform. Okay, so answer will be, I will give you a formula of a of I into 1 long, oh sorry, I will do it I minus 1 by 2. Okay, yeah, I think that will work. So that is not a, that is triangle. Yeah, so this is a small solution. I use once check it is working or not. 62012 6103. Okay, so I will, what I am doing wrong? Interesting. I less than n, I 0 and plus 1 up to n plus 1. This will be give me a sum, and I will take from 1 to n. Second part, that is good. A of I into a of I minus 1 by 2. That is not creating a problem. Yeah, that is not creating a problem. From 1 to n, I will taking for n. For the update, x must be greater than 0. Sum will be bit of x. Yeah, that's a problem. Uh, anyone can figure out the no. Like, what is the problem here is that I created bit for like I'm don't in like, if I update the value 2 4 1 here in this first query, and I will search for 2, like 1 is also there, so it will give me more answer. Okay, so you can see that the first answer is correct and baki are not correct. Okay, are incorrect. So because for every query I have to put the bit as 0, like bit of I is equal to 0. No, it is working fine. So I use a simple technique, bit technique, advanced data structure, and this problem is very simple, by the way. You can see only one formula, that is all know about this formula. So addition of some whole number, first n whole numbers, and here is, I'm using this only, this simple technique. So like bit is very useful if you have no, like it will type of segment tree, and but if summation of first n numbers and type of some problem, it will give in a simple code we can get in log n time. Yeah, this is okay. This is the next problem. You are given a string as all over Latin letters. The following operations can be used. Select one character A to Z that occur at least once in a string and replace all such character in the string. Okay, you are given integer k, the maximum number of operations that can be performed. Okay, so what we are given is that, let me grab my pen. Let's say I have given, take an example that will be fine for, okay, like CBA. Okay, so we have a CBA. This is a string. Okay, we have this is a string. Now we have to do at most k operations, and in each operation I will select anything, any character, and replace it with by the its last one, like the like for in the counting of a b c d, I will replace d with c, c with b, b with a, something like that. In a loop, z with a. So I need in k operations I need to minimize the or what I will say lexilogical small string I need to print. So let me solve this problem. So in the first operation, so my focus will be always in, this will be a greedy problem, so you can say that you always have to think about the first problem. Like I will always think about the first, like if you say like if k is equal to 1, let's say, so if apply the first operation then will be b b a, and if I apply the operation on the second one that will be c a a. But this is a lexically small element, this is a character, so it is always give a result, good result, if we are applying at the first problem. Okay, so we have to solve this greedily, and first we have to make it a, then step up. Okay, then we have to make this a, see that uh, k is there or not, we have sufficient k or not, according to we solve the problem. So let me solve this problem. cba, in first operation k is equal to 1, I will take this one, this c, so replace with b b a. In the second one k is equal to 2, now I will take b, so I will replace b with a, so it will become a. So this is the answer. So what I need to do, so in the algorithm there is nothing more to explain, but I will say like I will go forward if I can like already make. So what I will do, I will say like here is a b, or say d, here is b c e f. Okay, so here d, so here we need k operation, k is equal to 4 operation to make it a, and let's say k is equal to 5. I will don't decrease the 5 until I will reach the endpoint. Okay, what is the endpoint, and you will understand. In the first I will say k, here need k operation, that is 4 operation to make it a. To make it a, it need 4 operation, and I have 5 operations, so I can easily do to a. So I will take keep max appoint max, that is initial with 0, and I now I will at this position, so I will update max. I will say I can, let me say like I can I do it to, I can change it to a. I can say yes because it need 4 operation and I have k is equal to 5, so I will update the max. Max will be the maximum of, max is equal to max of the current max and the this value d, that is 4. Okay, so like what I am taking d is uh, d minus a. I will taking like a b c d, it's ASCII values, or I will say from not ASCII values, f g. Here is 0 1 2 3 4 5 c. Okay, here is if d okay, d is 3, sorry, that is my fault. D is equal to 3. In 3 operation I can, like in first operation I make c, second operation b, third operation d, third operation a, and its value is also 3. Okay, what values I will taking all these values, like if I convert it into a numbers, then what will the integer it will come, that is 3. So so I can convert up to 3 integers. Okay, that is 3, so max will now become 3. So here we go, is 3. Okay, now I will go to the forward. Now my point at this point, so I will see if it is smaller than 3 or not. Like if it is smaller, let's say d and b, it is smaller, then in first operation I will, it the string will become d and b. In second operation, if it is smaller, in any of the operation it will become same. If when it becomes same, then will be start decreasing with this one, so it will start decreasing with this. Okay, so if it is smaller than what maximum value we have, so we don't have need to care about this. Then we need to see c is also smaller, so I jump to the next element. Here is e, so I will see is e is smaller or greater. It is greater. For e I need, let's say k is equal to 4, otherwise this whole string will pass out. Okay, and let's say f is h, g is okay, g is okay. Okay, okay, so I will say f I will say f. Okay, and okay, let's see it is, so I will say it is more than 5, but it require only 4 operation and I have sufficient operation. I will go to the next and update this element, and max now up to 4 element I can do, up to e I can. If any element is less than e, then I will update it to make it up to a. Okay, now I will say g. So g is node less than mx, or and it is also node less than, so my current index is here. It is node, and the operation it require as 6 operations to make it to a, but we have smaller operations. So first of all I will minus k minus max. I will minus this operation. Now k will become 0. Why these operations? Because these operations I need. I from to make from here to here, I need to make everyone array, and I need mx operations, because in mx I will make all of them 0. So I will make let's say k is equal to 0. Now I'll subtract the mx operation. Now k will become 0. Let's say it will be 5, then it will be good. Let's say 5 and k will become 1. Okay, now I can apply in j one operation. So if anyone is from j to f, like j to f, I can make all j to f. Or if it is, let's say k is equal to 2, by default it is 2, so I can make all g's e to e. Like I can make in two operation, I can make j to e, and I can also make f to all e. All the big mid elements I can make it to e. Okay, this is what I need to do. Yeah, this is a good problem. So let's see the code of this problem. So we are just giving int n and k, int and comma k. So I will take a string sc yes. Okay. Mm-hmm. Okay, so I will take a vector. I will first take the maximum element mx is equal to 0, and a vector of char. I will say b of 26. I will take this is also good. If I can do, let me do I is equal to 0, I less than n, I plus plus. Now for I to n. Now if a of I, s of I, sorry, s of I minus a, its value is less than equal to mx, then I will say continue, and now it is value is greater, because if it is smaller, so I can easily make by decreasing it, I can make it to a. Now if it is greater than k, like if it is greater than k, Then first of all I have to minus mx, and I need to make up to this character, the last character. I can make up to last character, and this will be equal to s of I minus k, remaining k. Okay, now, okay, first of, if it is not greater, so I can say, and we have enough operation, so I will say mx is equal to max of mx comma s of I minus a. Up to this I can make everything similar. Now if it is greater, so first of I must subtract all the mx from the k, and I will subtract the k. Like if it is, let's say if it is d and k is equal to 2, k is equal to 1, I will subtract 1, so now last will become c. Okay, now from all elements, from all character, let's say of f first, f is equal to s of I. From s of I to f is greater than last, f minus minus, all these character I can make it to last character, this one character. Okay, so how can I make? I will say take an array, character, like let's say b of size 26, and for int I is equal to 0, I less than 26, I plus plus, and b of I, and I will say here b of f minus a, it will be converted to last character. Here what I will say. Okay, now first of all, for all character I less than and I plus plus, if it is already less than mx, less than mx or equal to mx, so first of what I will do, I will change this character, I will change this character, what value is changed, so s of I will become b of s of I minus a. So this character will change, like some character will change, I will say this character will change to last character, all these character. Okay, I will take, if nothing is changed, so I will simply take I is equal to a. Okay, wait, that is a problem. I plus a, so this will give for index 0 is a, for index 1 is b, c, d. Okay, I will increasing the I, and for here same thing here. So like say for d to c it will change, for d to b it will change to b, so it will store for, then it will be a, b, and it will convert d to b, c to b, and b to all, b is b. Okay, this will it will do. Okay, okay, if at xi is smaller than mx, then what I will do, I will say xi is equal to a, and I will output s. C A B C can do nothing. And S, it is B. Okay, it is B character. I will take the B character for item. If it is less than x, it will okay. I will make it continue. Otherwise, it's k minus mx, and the last character is here. From xi to last character, I will make f to the last character. Okay, then this is okay. Mx is equal to max of this is type int. Uh, it is always increase, so I can take it simply as of I minus a. Yeah, here I go. Wait. Yeah. So what I missed is this. I need to convert it to the character, because this is the value I need it to convert to the character. Now it is. Now here we go. Now see, it is got third is B and PB. B and PP. It converted. Okay, why it is converted? Oh, that's a problem. But B and B, B, A, B. Yeah, here we go. Because we have to break case 0 now. Okay. So this is the last problem of the day. You are given a position integer n. Let's call some position integer a without adding 0 palindrome if it remains the same after reversing the order of its 0. Okay, this is the palindrome number integers. Okay. Find the number of distinct ways to express n as a sum of positive palindrome integers. Two ways are considered different, but these are the same. You need to find the total distinct multiset of positive palindrome integers, the sum of which is equal to n. So what we need to find? We are given an n, and the range of n is 10 to the power 4. So you can see the range of n is not so high, it is smaller. Okay, actually we get up to 10 to the power 5, 10 to the power 5 something, but now it is kind of not so much higher range. So what I will see is, I will say n is this one. Okay, first I need to find out how many palindromic characters are. Like palindromic characters are 1 to 1 digit are always palindromic characters, like 1 2 1 3 3 3 5 3 5. These are all are palindromic characters. So let me find out how many are palindromic characters. So let erase all these things. Okay, so up to n is equal to, I have to make up to some 180 power 4. Yeah, to here how many are palindromic characters. Now 4 int I is equal to 0, I less than equal to n, I plus plus. And if palindromic count plus plus its count is equal to 0, palindrome of I is palindrome, then plus plus 0. And I hope so everyone know about the formula function of palindrome. It will give palindrome, and first of all I have converted into string. You can do any ways you want. These are simple from C plus plus to string, it will convert into string. And for int I is equal to 0 to I less than n by 2, I will see if a of s of I from front is not equal to s of n minus 1 minus I. First and last character I will see. If it is not equal, then I will say false, and otherwise I will return it. So I will define n is equal to s dot size. Okay, so this is a simple algorithm. See, to find the algorithm, to find it is palindrome or not. So you can see that up to 1 in, but the range is 1 4 in 10 to the power 4. Wait a minute, only 500. Okay, so basically we are just given, if you see that this are little bit trick prone, but if you see that where we end up is we have 500 elements and we have to 500 elements, like 1 2 3 blah blah blah. I have 500 elements, and such that its sum is equal to this one. This is something like, you can say, deep coin problem, or you can say, or it is a partition problem, like participate in such that its sum is in this way. Okay, so it's simply a classic DP problem. Oh, you can see the partition classic DP problem. So what I will do is I need to apply a simple DP. Okay, for what DP will hold, like, at the beginning 0, like 0 is true. 0, how can we take the 0? The empty one. If I take the empty set, its sum will be 0 2. So to take the 0, this is one possible way. So dp of 0 for all i's is this one. So I will make a dp of, I will not say dp, I will say array a of size n will be this one up to m will be 500. Okay, and for 0 for, so I will say, I will make how many ways I can make 1, how can make many ways I can make 2 3 and so on. This will I will do. So what I will do, I will say, if like, if I make 0, let's say I have 1 2 3 4, a simple example, 5, and I have to make 11. Not 11, it will be so much. I will make 4. Okay, I will make 4, and I have these, all these are, let's say these are the elements. So first of all, I will create, like, for 0 there is one value. Okay, I have the empty array. I will say I have 1. Okay, for now I will check for 1. So in how many ways I can make 1? For making 1, now I have empty set. This is the empty set. Before that, before it is 0, so I will start from 1. So I can, if I increase, like 0 plus 1 is 1, so now my empty will be, so there is one way I can make 1, that is 1. Now how many ways I can make 2? Now I'll see, for 1 I will iterate over these the elements. I will say, okay, my Siri is on. Fuck, man. So 2 minus 1. So the result will be, how, in how many ways I can make 2 minus 1 plus, and in this set I will include 1. So in how many ways I can make 1 is 1. So that will be, and this set is 1, and I will include 1. So this is my first set, and second one is how many ways. Now 2 minus 2, second element is 2, now it will be 0. So in how many ways I can make 0, and I will put inside 2. So 0 is just empty, and this sum is 1, so that will be 2. So for making 2, I have now 2 sets. Similarly for 3, I will check for 3, in how many ways I can make 3. I will say, 3, for 3, I first element is 1, 3 minus 1, in how many ways I can make 2, and in 2 I will insert 1. So I will make 1 1 1, and here is 2 comma 1. In all these two I insert 1. That's what I am doing. Similarly, now the second element is 2, so 3 minus 2. In how many ways I can make 3 minus 2 is 1. In how many ways I can make 1? But that is only 1. Similar to that, like these, according these, so like according to this, we are just doing the problems. Okay, so what is the DPs? So if I give that DP solution is one line solution, like how can I make I comma j, or I can, how can I make 5? I have element, I have index 3, so that will be equal to, in how many ways I make 5, that is I, for previous, up to previous indexes, like j minus 1. In how many ways I can make this, plus dp of I minus 1 minus what is the current value of like a of j, not this current j, like in how many way I already make it, and plus like let's say a of j 3, then 5 minus 3 is 2. In how many ways I can make 2, that is the way. So according to this is the one formula that we require. Let's solve the problem. I think that's a simple dp and you can find it anywhere, like, so if you say this is the classical problem, dp solution, partition dp solution, geek for geek we have, yeah we have geek for geek, yeah here it is, and this is to this is sum of partition j is equal to power, yeah. mm, yeah here it is, the you can find anywhere in the lead code, everywhere it is there. This is a classical problem, you don't need to worry a lot. So first of all I need this one. Okay, so I will say make and m all this thing, wait a minute, I will make this, I will say int n is equal to 4 e की power 4 into e की power 4, e की power 4 plus I will say 10, and m goes up to 500, so I will say 501. Okay, we already counted that how many m will be, that is 499 501, that not a problem. After that what else we need are dp, int dp of size n comma n, that what I need, int dp what I say, okay I need constant. Okay, here we go. So first of all I up to n I will find how many integers are palindromic, and I will create a vector of type int, that is palindromic pal, and say how many are, if it is a palindromic I will insert into this dot pushback I. Okay, now we need to apply the, so first of all row I is equal to 0 to I less than m I plus plus I plus plus, I will make 0 I can make with anyone and it will be 0, sorry 1. Okay, yeah, and then I need to apply for int I is equal to I from 1 to I is less equal to n, if less than is also because I already included 10, for int j is equal to j from 1 to j is less than equal to n less than m and j plus plus. This is the dp solution, and if so dp of I comma j, dp of I comma j is equal to dp of I comma j minus 1, previously how much we calculated, and dp of I minus palindrome of I j. So here I take j up to 1, so I have to take it j minus 1. J is 500, palindrome will be not having 5. Okay, that will be okay, I will be making minus 1, that is also fine, perfectly fine. J will be up to 5 not 2, j will be 5 not 1, and minus 1 will be 500. Yeah, I will see that. Okay, yeah, of j. Now I have to see that this value is greater than 0, otherwise this will be in minus. or I will say, yeah, that is okay. This must be greater than equal to 0, नहीं तो ये वैल्यू नहीं आएगी, तो सिर्फ मैं यही रखूँगा. Yeah. Okay, here we go. I think we are done with problem. Just we need to find, and we are just given n, and we need to found dp of n comma n minus 1. Seven 74. So you may be confused why here I am taking n. Okay, so like in this dp there will be a like a 2D matrix, so up to n, I'm taking some, how many ways I can make some. And if it is m, like you say, if I need to take up to all the elements that is smaller than n, like I can't take, like it is okay if you like, if you make for all the variable, like for all the test case you have to run this algorithm, that will then it will be give a TLE, because 10 to the power 4 into 10 to the power 4. So like if I run this for all the test cases, I have test cases 10 to the power 4 n is, and per test cases the DP will take 10 to the power 4 into 500, 4 into 10 to the power 4, that will be 10 to the power 6 and 10 to the power 4, that will give you TLE. Okay, so that is a TLE. So we need to calculate only at once 10 to the power 10 TLE, and once will be give only 10 to the power 6 next. And say the question here stays like why we need m minus 1. So if any value, like you can say we only need, like n is 100, and we are just go up to n is equal to 500, and the 500 element will be approx 4-digit number, let's say 4141. This is the number and this is greater than, so I will say like then this will not happen, like I minus, like if I is equal to 400 up to 400, this value don't run. Okay, this will not run. So if this not run, the answer will not increase. Okay, so this will only count when it is smaller, so we don't have to care about if it is greater than, it is not count in our answer, that's not a problem. Okay, I think so. Okay, bye bye. And if you need, like I have to improve somewhere, so please comment on this. And yeah, thank you.